Greetings to all. My name is Lakshmi Saraswat, Senior Assistant Professor of Department Computer Science Department. My video is today for Computer Organization Architecture Introduction part. In today's video, I will cover the content Introduction, Evaluation, von Neumann Architecture. What is computer organization? The computer organization or CO deals with the way hardware components operate and the way they are connected together to form a computer system, as checking of computer parts operate as intended. We know the computer organization is a combination of hardware which are connected each other. So in computer organization, we are only dealing with the hardware component connection. As well as in computer architecture, it deals with the structure and the behavior of the computer system. In computer architecture, we deals with the how these hardware component are connected, are attached, and what structure they are making, and how this structure is behaving. So this all can be these things are deals in the computer architecture. It includes information, formats, instruction set, techniques for addressing memory. Computer organization and architecture evaluation of computer. Quest to develop new automated machine has led to the rise of the development of computers. Mechanical devices like pulleys, gears, vacuum tubes were developed, and the invention of the first computer was called ENIAC. Semiconductor transistor developed and the journey began. So here is the picture of first computer ENIAC. We can see. Now we comes to the von Neumann architecture or von Neumann machine. We can see in this machine that there are 5 components. The von Neumann machine consists of 5 components. These components are input unit, output unit, control unit, arithmetic and logic unit, and memory unit. Input unit is basically what from where the information is get accepted. So there can be any devices like mouse, joysticks, and floppy drive, core drive, and modem. So these can be our input devices. And output devices can be video terminal, any display, printer, plotter, from where we can get the output, where we can see the output. So the output devices includes those types of devices from where we can see the processed information, the processed work, which is assigned to the computer central processing unit. Here in central processing unit, we have control unit and arithmetic logic unit. Arithmetic logical unit is responsible for multiplication, addition, and division, whereas control unit is responsible for ALU memory and input, and output unit, its combination is done in a control unit. So it sends the signal to the other units to make a control. These two, when comes together, makes a central processing unit, and this CPU can interact with memory unit. Memory unit, it can interact in both ways, means bidirectional, as we can see. So this here is the input which is getting this system, and output is given by output devices. So the whole architecture is known as the whole machine, this process is known as a von Neumann machine. Now we comes to the basic computer organization, one name machine architecture. We can see here that CPU and memory subsystem is connected with the buses. The information which is passes in the computer is only we can pass the information by bus. There is no other way to pass the information. So here we have in our computer systems, we have three type of buses, that is address bus, data bus, control bus. Here we can see the address bus is having a unidirectional because CPU sends the address to the memory where it should be work. So it is sending the address, so it needs only one direction, so it is unidirectional. Another one is data bus, that is both side we can see bidirectional, can accept the data and send the data. Control bus is used to control the signal, to send the signal. So it is bidirectional. Here are input-output subsystems and devices, which makes a device. So basically we have three key concepts of one human architecture. Data and instruction are stored in a single read-write memory. Contents of memory are addressable by location without regards to the type of data content there. Execution occurs in a sequential fashion unless explicitly modified from one execution to. Computer system have these components. We can see the system components. The system components are CPU microprocessor, memory subsystem, input-output subsystem. So here we can see the processor system and here is the input-output subsystem. In processor system, we have main memory and CPU which is connected with the help of bus. These can be of three types which we have already discussed and we will discuss more about it later. And we can see this processor system is connected with input-output subsystem from where it gets the input, gives the output. So here are input-output devices. Next come the system buses. System bus include data bus, address bus, control bus. And these buses are connected. We can see how they are connected to each other. Here is CPU, memory, input, output. So we can see the data bus is connected to the memory, memory and input, output. CPU is connected with all. Address line is connected to all, right? And control signals are also connected to all. But the direction will be decided as we have discussed before. Now we comes to the instruction cycle. The instruction cycle have the three types of cycles. It have the three stages, that is fetch, decode and execution. First, we start the procedure, then fetch next instruction, then execute next instruction, and then halt. Then the execute next instruction is goes to the, then again after execution goes to the next instruction. So this is the whole cycle is which work for the instruction cycle. This whole data is taken by M. Morris Meno. Thank you.